Triangle congruence theorems. We know that the two triangles are said to be congruent if their corresponding sides are congruent. Similarly, if the corresponding sides and angles of the triangles are congruent, then those two triangles are also congruent. So all the six corresponding parts of this triangle must be congruent. Now, using this AAS theorem, we don't need to identify all the corresponding parts of a triangle. This AAS theorem means angle-angle side theorem, wherein if the two angles or two corresponding angles are congruent, the other two corresponding angles are also congruent, and the corresponding sides are congruent. So this information is enough for us to say that the remaining parts or corresponding parts of this triangle are also congruent, which makes these two triangles congruent. Okay, another example. So if these two corresponding angles are congruent, the other two corresponding angles are congruent, and the corresponding sides are congruent, so this information is enough for us to say that the remaining corresponding parts are also congruent, which makes these two triangles congruent, no matter how it is oriented. The other one is the HL theorem, or the hypotenuse leg theorem. So this triangle is a right triangle if one of its angle is a right angle or a 90-degree angle. And in front of this 90-degree angle is the longest side of a right triangle, which is called the hypotenuse. Then the other two sides of this right triangle are called the legs. Okay, this HL theorem is only applicable for every right triangle. So this is the key feature of a right triangle. For example, these two hypotenuse are congruent. Then the two corresponding legs are also congruent. So these two parts of a right triangle, they are enough for us to say that the remaining parts or remaining corresponding parts of this right triangle are congruent, which makes these two right triangle congruent as well. So another example. So if these two hypotenuse are congruent, then the other corresponding legs are congruent. So the remaining corresponding parts are also congruent with each other, which makes these two triangle congruent as well. How about this angle side-side? Okay, let's try to explore. Is there such an ASS theorem? Let's see. So if these two corresponding angles are congruent, then the next, the side or corresponding sides are also congruent. Then the next consecutive corresponding sides are also congruent. So visually, we can see that these two triangles are also congruent because the corresponding parts are also congruent. But it is not always the case because uh, this situation might be interpreted in a different way, which creates an ambiguity. For example, if this angle is which is corresponding to this angle is congruent, and this side is congruent to its corresponding side, then we have another side here congruent to this side. But since we have no information about the measure of this angle, so we can position this side and swing it over like this. Since the corresponding sides are still congruent, but it is in a different inclination. And it forms a triangle. And if we're going to compare this third side of these triangles, we can see that they are not congruent. Therefore, if one of the corresponding sides of two triangles are not congruent, then the two triangles are not congruent. Therefore, there is no such ASS theorem in triangle congruence theorem.